Hello everyone. In this video, we'll be solving matrix chain multiplication. So this is a very famous problem on DP, on partition DP. In this problem, what we have to do is we have to find the task, minimum operations to multiply a set of matrices. Like if we are given uh, a matrix A and B, and then we have to find the minimum operation that we will require to multiply both the matrices. So let's see with the help of example. There are given four numbers over here. These four numbers represent three matrices. 4 and 5 is one matrix, 5 and 3 is another matrix, and 3 and 2 is another matrix. So the multiplication of these three matrices require 8000 operations. And in the second operation, 10 and 15 is one matrix, 15 and 20 is another matrix. So how we will solve this question? Will we will try to solve it using recursion, because we need to we can multiply the strings in we can multiply the matrices in different way. Like if we are given A, B, C and D, then we can say that first multiply B, C, D and then multiply A with it, like this. First multiply this, participate the array into this, and this BCD will first multiply and then after A. Or another one can be like first we multiply AAB and then we multiply CD with it. So we have to find the minimum operations to multiply this. So to this we have to mm, uh, so we have to partition the array. Like first we do this, then we do this AB, then we do this ABC, and we have to find the minimum of this. So this can only be done by using recursion, because we have to find all the possible ways. So we'll just find it, and the minimum operation to multiply two string is this. Suppose like we have 10 21 matrix, and 20 into 30 is another matrix. So how, when we can multiply two matrices, like if the column of first matrix matches with the row of second matrix, then we can multiply it. And the minimum operation required to multiply the both of matrices, first of row first row of first matrix into the common row and column row of column the common column of first matrix and common row of second, which are both equal, like 20 and into 30. This will be our sorry minimum operation to multiply these two matrices. Okay. And if so, how we can partition these two arrays? So what we'll do, we will just take two pointers, at one at first, which is called I, and second at j. So these two pointers will point, sorry, we will take the I pointer at j because it represents first matrix. From second from first index onward, it represents the first matrix. Like 1 2 is first matrix, so I have put I at 2. 2 and 3 represent second matrix, 3 and 4 represent fourth matrix. Okay, and what we will do, we will loop it from I to j, and we'll try to partition it. Okay, so first we will participate it this. We'll say like this represents three matrices A, B and C. So first we will say I will first break this into A and BC, and the next I will break in AB into C, and these two only be done. So I will put my I will traverse a k variable from I to j minus 1, because only two partitions can be done. One is between A and B, and the second is between B and C. So we'll just uh, travel uh, travel it and traverse it until j minus 1. and we'll call the functions to give the minimum values. So let's try code it, and I will further explain you. So let's just create a function help int I, which represents the starting, which points to the first matrix, int j, which points to the last matrix, vector int ampersand array, this represents the matrix array, and int. Okay, now what we know that if there is only single element, so I and j will be both equal, so we'll just return 0, because if there is only single element, then the minimum, then the operations required will be 0. And what I said to you that I will traverse the array from I to j minus 1 to cut it into parts. Okay, so I will just traverse it from k to k is less than j minus 1 and k plus plus, and we'll just count the steps. So when there are, okay, so let me tell you, when there are like a, b, c and d, so when there are these three elements, these three matrices multiply, function goes and calculate these, the value of these three functions, these three matrices calculated over minimum operation, and this and the single. So the what I'll do, I will say, so there must be minimum operation required to multiply. Now this now this BCD will be a new, a single matrix, and this A will be a single matrix. So the minimum operation to multiply these two matrices will be, at that time, will be array of I into array of k into array of j, plus this is the minimum operation required to multiply two matrix, and after that we'll call help function from I to k, and we'll say just go and give me the value of minimum operation required to multiply the multiply the matrix from I to k, and another function which we will call from k plus 1 to j, and will go, and there I will create an answer equals to 1e9, because we have to find the minimum, and every time we find the steps, so we will store it in a variable and find the minimum of answer comma steps, and we'll just return the answer. Okay, so let me just call it from here, return of help 1, because I have kept the first, it represents the first element, and minus 1 and array. Let's check it. It gives wrong answer, so let me see what is wrong over here. Okay, so there will be not be array of I, there will be array of I minus 1. Now we'll return as you can see, this solution gives time limit existed because the time complexity of this solution is exponential, so we need to optimize it. So we'll just create a 2D array memorization technique to compress its time complexity, as the values, there are only two changeable values, like I and j are only changeable. So we'll create a 2D matrix of size n, because the values of j can range from 0 to n, and the value of I also can range from 0 to n. So we'll just create a 2D vector. So vector int dp of n comma vector of int n comma n minus 1, and we'll just pass this to the function, and we'll just copy it over above, and before calculating we can also check if dp of I comma j not equals to minus 1, then dp of I comma j and we'll just pass it over here also. TP, TP, and before returning we'll just store it in our TP array. The time complexity of this solution is big of n square, and the space complexity is also big of n square because we are taking extra space. Okay, so let me just submit it. So guys, as you can see, this is accepted. Thank you for watching.